Welcome. This video focuses on the assignment operator. So we've already talked about this rule of three, and we've seen the destructors and the custom copy constructors and why we need to worry about those. If we have a class that manages memory, it is up to make sure that when we get destroyed, we free that memory. That if we get copied and we want to make a deep copy, we go copy our memory into the new object. Well, today we're talking about the last part of that, which is a custom assignment operator. Right? And so it's the operator equal symbol, the assignment operator, and what it'll do is it'll take in another object, a reference to another object that we don't plan on changing, and use that to copy into the current object. Right? And once again, the idea is if we're copying course 2 into course 1, what I probably expect to have happen is something like this, right? Where I copied course 2 into course 1 or vice versa, and I end up with two distinct objects, each with their own storage. Versus a shallow copy where I copy course 1 into course 2, and they each have their own capacity and number of students, but they share the same array. Something like this is bad news because as soon as I go and say I add a student to course 1, so the number of students becomes 2 and there's a second thing in there, well, this guy has 2 students in there but thinks he's only got 1 student. So then if I go add a student to course 2, he's going to overwrite that slot number 1, and now he's going to have messed up course 1. As soon as one of these gets destroyed, it's going to delete this array, and the other one's going to have this bad pointer. So what we need to make sure we do is provide a deep copy. And the basic logic for doing a deep copy is going to be just like the copy constructor. Right? We've seen the copy constructor before. Anything that's not a pointer, we just copy over from the other guy, this course, to our own variable. We copy over course name to course name, number of students, number of students. And it's only something that is a pointer off to dynamic memory, like our students, that we have to allocate our own array for and then copy over one at a time. Right, and this copy constructor, just to review, right, it calls like this. If I have course 1 and I say make me course 2 and pass it course 1, we use the copy constructor. We can also get the copy constructor if we initialize as we declare. So this, even though it looks more like assignment, this will use the copy constructor. I'll get this message, assuming I have that in my custom copy constructor. I have a C out there. I will get, if I do course 1 gets assigned into this new course, course 2, I'll use the copy constructor. So the time when we really use the assignment operator is if I have 2 existing objects and I then say, hey, take course 1 and assign that into course 2. And that, if we don't provide our own version of it, that's when we have potential to really blow things up. So, just like the copy constructor, you get a default assignment operator. And the default one does a shallow copy. Just copies over each piece of information one by one, which means we have a shallow copy because we copy the pointer to this pointer, and so we have two copies of the same memory address. If we're managing memory, that's not what we want. So we've got to go provide our own custom one. We have to copy over the basic information from the other thing. We have to make our own memory, and we have to copy the values from that memory. In addition, there's a couple things unique to the assignment operator. We're expected to return a reference to whatever we just copied because we're allowed to have chained assignment. A equals B equals C. We don't necessarily have to provide this, but usually it's expected that if we have an assignment operator that we're going to return a reference to an object. The other big thing that's different is we're working with an object, right? The only way that this gets called is if we have 2 objects already, course 2 and course 1. So course 2 in this case already has some memory. It's already in charge of a list of 10 students. So we've got to get rid of that existing memory, and we also have to be careful that we don't box and try and copy something into itself. So what this actually looks like in code, operator assignment, we take in a reference to some other course that we promise not to change, because we're only going to change the thing on the left-hand side. Right? If we do course 2 gets assigned course 1, that's interpreted as course 2, call the .equals function and pass it course 1. So we're not going to modify course 1, we're just going to take stuff from it and copy it into course 2. And we're going to return a reference to course 2 so that you can do a chained assignment if you really want. Like I said, not something we use a whole lot, but that this process is only going to make sense if, after we're done with something like y gets assigned the value 2, if that's interpreted then as having the value y, so that then we can chain it on into x. So what we need to have happen, here's kind of the model we're working with. We've got course 1, 5 slots for 5 students and 1 student in it. Course 2 with slots for 3 students and nothing in it. And we're going to copy from course 1 into course 2. Right. What this means is course 2 dot equals the other. So the other one there is course 1, and the implicit this is course 2. So if we start running the assignment operator code, here's what it would have to look like. Right? Just like I said, it's kind of just like the copy constructor. We're going to copy over the basic information. Nothing wacky has to happen there. Right? I just take the course name from 1 to 2. Right? From this other course, which is course 1, I copy that into course 2, which is this thing. So course name means course 2. Other course.course name means the one from 1. Copy others num students into ours. Copy others capacity into ours. Now, obviously we're a little out of sync right now because we think we've got an array of size 5, but we really only have a pointer to a size 3. But that's okay because we're about to delete our old storage. We're just going to toss our old storage and make a new chunk of storage that's got the right size. And so that's the next step. We kind of scrolling down here, we just finished deleting the array. We'll allocate a new array of the correct new capacity. So now I have 5 slots. And then we need our for loop to go through and copy one by one things from the old array into our new array. And so we do that, and now we've got a nice deep copy of the other course. Right? Course 1 and course 2 are 2 distinct things that both happen to have the same information. And then finally, return this object, right? Dereference the this pointer to get the course 2 object, and then return that. And we actually are going to return that as a reference so that we could do the chained assignment if we really wanted to. Now, you may have noticed we skipped over a little bit of code at the start. And that's to avoid self-assignment. If I set up a course and try and do course 1 get set to course 1, that's perfectly valid to type. But it's going to actually blow up my program or just clear it out or do something else weird. And here's why. Imagine I don't have this little chunk of code that we're skipping for now. And I say course 1 gets assigned to course 1. So I copy from course 1 to course 1, its name, its students, its capacity. Yeah, no big deal. Now I delete my students array. We're in trouble. We just lost track of whatever students we had. We just lost track of Peter Pan. That memory is gone. We allocate a new array. Well, okay, great. We've got a storage array now. And now we go copy from the old array into the new one. And this is where our program possibly completely blows up. Or maybe it doesn't blow up, but it copies over meaningless gibberish that's in memory. Right? Something bad is probably going to happen. So that's the point of this line up top. To avoid self-assignment. If the address of the other guy, so this other course, I get its address, and if that's the same as the this pointer, right? If this is a pointer, it's got a memory address. If the address of this is the same as the address of the other guy. We are the same thing, and I don't want to do all this work. I'm just going to skip it. So we typically want a clause like this. Hey, if this thing is not the same as the other thing, go ahead and do the copy. Otherwise, skip all this, and then no matter what, return this object. For the return this object as a reference to do the chained assignment if we want. All right, so kind of boiled down, the basic recipe is if I want to do an assignment operator, which if I'm managing memory, I better have along with my copy constructor and my destructor. For the assignment operator, I verify that we're not self-assigning, so I have something like that. I then copy the basic information. I delete my old memory. I make new memory, and I copy from the other guy into my information, right, to my new storage, my array. And then no matter what, I return myself. So a lot of the same work as the copy constructor, with the differences of we have to worry about deleting the old memory, we have to make sure that we're not doing this to ourselves, and when we're done, we return ourselves.